Absolutely. Thanks a lot, Elaine. And thank you all for joining our webinar today. You will see my email at the end of the presentation. So a little heads up about what we're going to talk about during this webinar. For those of you who may not be aware of our brand, we're going to talk a little bit about Intracom Telecom. And then we're going to talk about the challenges we have today when it comes down to the resources, the high demand for capacity for the wireless links, and how it's very common to have maxed out resources for those links. What is the solution that we propose? We can see E-band, the dual band application that we have, and basically redefine the concept that we have as far as how long you can have an E-band link to be. And at the end of the presentation, there will be a Q&A session. Now, Intracom Telecom, you're looking at a picture of our global headquarters there, the campus that we have. And Intracom Telecom is a global telecommunications systems and solutions vendor. We have been in the industry for more than 45 years. We have over 1,700 employees worldwide and local presence in 16 countries. We also have a very big facility for production in the EU, as well as 3 R&D centers. Now, some of the core offerings that we have, as well as the markets that we serve, well, in addition to the obvious, which is the wireless network systems we're going to talk about here, we also have telco enterprise software solutions. This is the second core offering right here. And this refers to the IPTV platform, basically. This is a very big product out of the Atlanta office where I'm talking to you from. And we also have smart city and surveillance solutions, as well as energy solutions for data centers. Now, based on all of these, you can understand that there's a lot of markets that we are serving, such as the telecom, utility companies, smart cities, healthcare, public sector, as well as others. Now, let's look at our wireless product portfolio. As you can see, it's pretty large here, but it also covers all main aspects of a network. So you got the transport side over here, you got the aggregation, as well as the last mile access. Now, there are 2 main technologies that we cover all of these network segments with. The first one is the point-to-multipoint, which is this part right here. And then point-to-point, which is this band right here at the bottom. Point-to-point specifically is divided in the microwave section, which is this one right here. This has not been introduced into the North American market as of yet. We're working on it. But the millimeter wave is the one that we're going to focus today, and specifically the GX80, the UltraLink GX80 10 gigabit radio that we have. I also want to mention that every single, in addition to the radio, every single antenna that is part of our solution, it is an inside design and manufacturing by Intracom Telecom. Specifically, it's Fine Telecommunications that you see here on the right that design and produce all of these antennas. And Fine Telecommunications is a member of the Intracom Telecom group. Now, let's look at today's issues. Common things that we know of on the network side. First of all, you got high utilization rates. All of the majority, at least, of the existing links, they may not have enough space for growth. The demand is there, but everybody's thinking alternative solutions, how to make or options to make it work and cover the demand. The unlicensed band radio limitations. Unlicensed band is fantastic for the most part, cost effective, but for the most part, as we all know, their best effort because of the possibility of interference. As far as the service is concerned, a lot of times, because the demand may be there, but the supply is not there, You can have reduced or even downtime of the services. And that obviously leads to the very negative effect of customers being dissatisfied with the service because the supply is not there. So what are the options that a lot of the companies are considering? Well, if you have an existing wireless link infrastructure, such as microwave, what you are probably thinking is the very big topic lately, which is fiber, or even leased lines. Those are excellent options, but that means that whatever existing capex you have from your existing wireless link infrastructure, that is not going to be used. And on top of that, such as the fiber case, it may not be available, especially in the rural environments, or it may not be very cost effective to deploy. So the second category of options is the reuse of the existing microwave infrastructure that you may have in your network. Now, the first sub-option here is to get additional channels. So whatever that microwave infrastructure you have, you're thinking about getting additional channels. Yes, this is a higher cost for the case of licensed microwave links, but those may not be available. And also, there's also the option the unlicensed may have severe interference. So that may not work. Another sub-option here in this category of the reuse of your infrastructure is the insertion of a second radio. But that may not necessarily be a permanent solution because pretty soon, let's say if you have 1 gigabit capacity microwave link, adding another one is not going to be a permanent solution. The demand is going up much faster than we want it right now. So eventually you're going to run into the same situation where you're in right now. On top of that, for the unlicensed band, for the most part, multi-channel and multi-ODU configurations are not possible with the unlicensed band radios. So what is the solution? Well, E-band is a fantastic option, but the key element here, as you can see on the title, is a robust E-band link, something that's gonna perform well without huge variance. So let's look into this. Why E-band? Well, E-band, for those of you who may not be aware of this band or not very used to deploying E-band links, it has a lot of spectrum. For the US market, you're, excuse me, you're allowed to use up to 2,000 megahertz channels, and that's how you deliver up to 10 gigabit capacities. Now, this is license exempt for the US, and that means that the only thing you got to do with the FCC is just register the link. So this is a very low OpEx solution. In addition to that, we have to consider that E-band is a quality enabler, not just a capacity enabler, comparing it to the unlicensed band radios. So we said that the spectrum is there. You can use a 2,000 megahertz channel to deliver up to 10 gigabits. That's the capacity enabling part. But at the same time, it's quality enabler because that transmission lobe is extremely narrow. For example, for a 2-foot antenna on your link, that could be down to 1 degree. So you can imagine that when you limit the interference because of that the characteristics of this transmission, then you have quality of service that you can implement within this transmission. So it's great quality enabler. In addition to that, because you have the capability of delivering 10 gigabits, you're not going to be using single gigabit ports on your switch. You're going to go with a single 10 gigabit port. So therefore, you're saving ports on your switch. And at the same time, you have power savings compared to a traditional multiplier of microwave links. So instead of reaching the capacity with microwave links, multiplying single gigabit radio links that would consume 10 times the radio power, you have a single radio that delivers the 10 gigabit, again, consuming the power of only one radio. But then the big question is, what about link length? How far can you go with E-band? This is a very very good question. And the answer that is shown here at the bottom is that you have to consider the system gain at 10 gigabits because that is going to drive the long link performance. Now, we're going to talk about again that this is not just a feature. The system gain at 10 gigabits is what really drives the link performance. And we're going to talk about this throughout the webinar here. Why are we considering the system gain or the highest system gain in the market as an important factor? Well, as we mentioned, it's going to provide, it's going to give you the longer link distances. It's going to reach out further. But in addition to that, you're going to have much more robust links during the weather anomalies. So the capacity is going to be a lot more stable. In other words, the link is not going to drop that easily from 128 QAM down to 64. It's going to stick around for much longer. Same for reliability of the link. It's going to be active for much longer. Now, when it comes down to CapEx savings, in addition to obviously, you know, if you don't have repeater radios and you're saving on the from the radio, the CapEx of the radio, but you can also save on the antennas. Just to give you an idea, we have seen, you probably guessed it, the reason for the webinar is because Intracom Telecom's radio is the market leader when it comes down to system gain at 10 gigabits. So when we are comparing the performance of our radio, the 10 gigabits, with other vendors, we can see for that system gain a difference of up to 10 dB. And you can imagine that when you have such a huge difference in system gain, that can translate to savings on the antenna side that can be on both sides of the link or just one. Now, think of in terms of the same performance comparison when you have a 2-foot antenna link, and then all of a sudden when you introduce the radio with highest system gain, that's where you can go with a 1-foot antenna. And that automatically saves space on the tower, which is very crucial, you know, if we're talking about a rental space. But let's compare a little bit on an example how that works out. So this is your traditional E-band link. This could be any vendor. And if we want to understand what is Intracom Telecom's offering and benefit here, we have to consider what happens at, you know, the distance that we typically consider, you know, quote unquote limit. Usually if we're talking about, again, on the average, you know, this is not for a specific case, this is like an average throughout the US or North America for that matter, we normally consider 4 to 5 miles. We've seen some of the vendors cannot even make the modem sync at 5 miles when we're talking about delivering of 10 gigabits. So if we're talking about 4 to 5 miles, what we need to compare is against the highest, system gain in the market that will take that link even further. So for the same availability, I provided some numbers here that could be 8 miles and 9 gigabits. Those numbers are an actual deployment that we have. And those numbers represent a deployment with a very high rain rate. Specifically, it's in Florida. We all know how rainy that state is. And we're going to talk more details a little later on. Now, we're talking about a real example of having a link that syncs at 8 miles, actually higher than 8 miles. And it does reach 10 gigabits. It's just that the specific client that we have, they consider 9 gigabits. They do all of their design based on 9 gigabits, even though it reaches 10 gigabits. But somebody may say, okay, I get the point. You got a great link there as a reference, 8 miles, delivering 9 gigabits, but I have dual band. And I get this fantastic performance, you know, at a very high distance, long distance. I use it with another microwave and it works fantastic. Well, the concept here has the following problem. If you're going to invest money and go for the E band, in other words, if you have a microwave and you add an E band to deliver the high capacity at the long distance, the proper choice, if you have options, is to go with a radio that can deliver the highest capacity at the longest distance because of that system gain. In other words, you're going to get a radio that is designed to perform better. Otherwise, you're going to be relying on your microwave link to do most of the work for that dual band. So the point here is not to consider system gain at 10 gigabits as just another feature, but understand that when you're talking about long distances, if you want to reach that, have that link reach further out there, it makes sense to consider and understand what the benefit of system gain at 10 gigabit is, because that is designed to do exactly that, give you the highest capacity at the long distance. So basically, it can be considered as bridging the urban and the rural area in one link. And this is especially important for rural areas that fiber may not be available. So get that link that syncs in that has great performance. We're going to talk about the cases of severe thunderstorms and what happens there, but this is the fundamental criteria that should be considered. You got to make sure out of all the options, you get the system gain, the highest system gain that will deliver that performance. So what? Now we talked about we talked about the dual band option, and what we of course we have to offer that because you do not want to leave that link susceptible to weather. This has nothing to do with the specific vendors. This is a case of physics associated with a band. E band does not have the same transmission characteristics as microwave. So for the extreme cases where the weather becomes a problem, such as severe thunderstorms, you got to make sure that there is a case there to help you with that situation. And for this case, Intracom Telecom solution is the dual band overbuild. Let's look into this. So overbuild means that you have an existing infrastructure. So this could be your microwave link that could be maxed out, as we said, and you don't have enough room to offer additional services. You build on top of that, parallel on the same tower, the E band link, specifically the UltraLink GX80, as I've been talking about here. You do not dismantle your existing microwave antennas. These are two parallel links. So you get, for the same distance as the microwave, that happens to have better performance compared to E band, but not as much capacity as E band, you get a satisfactory availability for the 10 gigabits. This is the key fundamental driver of the UltraLink GX80 with a 10 gigabit system gain. Now, we also have transitions. Obviously, when the weather does not permit that great performance, you have to have transitions between the E band and the microwave. We do that with simple and quick transitions using G8032. This is a ring protocol. Very soon, we're going to start the deployments without the G8032, but with RLA. I'll be more than happy to talk about this. If you want, you can contact me, email me, and we'll go over the details. Now, this concept is a great market-leading system gain solution that is associating basically the quality of service enabler for E band, in addition to the capacity enabler because of that spectrum. And in our specific case, it is IP/MPLS ready. So if needed, you can use IP/MPLS or introduce that into your network. Now let's look at how this works. So this is your traditional, and again, this is how the dual band overbuild works. So this could be your existing microwave link. For the sake of the argument, let's consider that this is 1 gigabit. But as we all know, recently, demand is there, but the supply may not be there. So let's consider that you don't have enough capacity on this microwave link. So in other words, no room for extra services or customers. So that 1 gigabit link, what do you do with it? We add the dual band. The dual band concept that you see here is basically the additional set of antennas on the tower. This will be your E band UltraLink GX80 overbuilt on top of the existing microwave in parallel. That's how you get the dual band concept. In the next step, you have the UltraLink GX80 E band link become your primary transmission path. That is 10 gigabits. So this is the active, and what you did effectively, you upgraded your existing 1 gigabit microwave link all the way to 10 gigabits. As we mentioned, E-band may not perform that well during weather anomalies. And for the sake of the argument, let's say because of thunderstorms, you have a drop in the traffic, reduction of the modulation, and let's say 5 gigabit capacity. Still, 4 to 5 gigabits is much better compared to the initial conditions that you had with your microwave at 1 gigabits. The crucial point here is that this 5 gigabits, because of that highest system gain in the market, is going to stick around much longer, right? The less system gain that 10 gigabit capacity has, then you're going to drop to below that. So that availability at 5 gigabits is not going to be there. It's going to drop to 4 or less with other vendor radios. And for the sake of this example, we'll take it even further. We'll have extreme thunderstorms to the point where the weather halts the UltraLink GX80. And then what happens? If your E-band is now cannot transmit, then it automatically switches the priority traffic to your existing microwave link. So you don't lose your priority traffic. You go back to the previous conditions where all of your 1 gigabit priority traffic goes through the microwave. The good news is that this is only a few hours per year because those extreme thunderstorms are not that common for the most part in North America. And as soon as the weather clears, then the UltraLink GX80 takes over again. So the entire dual band link goes back to the high capacities of 10 gigabits through the UltraLink GX80. Okay, so we talked about how the highest system gain plays a tremendous role in the effectiveness of the link and the performance. We talked about the dual band overbuild as a solution to protect your priority traffic. Let's look a little bit about what this product is. We've been talking about the UltraLink GX80. Let's look into a little bit more details about that. But before we do that, why Intracom Telecom? Because it's an agnostic solution to the microwave. This can work for any licensed or unlicensed vendor. We have in-house solutions for brown as well as greenfield deployments. What we just talked about in the previous slides was the brownfield. You had an existing microwave link that was maxed out capacity-wise, and you built the E-band UltraLink GX80 in parallel without dismantling your existing microwave antennas. This is the brownfield. But we also have the greenfield application as well. This means that a single dual band antenna can take both a third-party microwave radio as well as the UltraLink GX80. You do notice here in the parentheses the flange cassette because that is a custom solution in order for us to interface with a third-party microwave flange on that other radio. So the case that we talked about, the reference case of a rainy deployment in Florida where the link syncs at beyond 8 miles at more than 9 gigabits. This was done with the UltraLink GX80, as we said. It's this radio right here, 10 gigabit full duplex radio. But I also want to take the opportunity very briefly talk about the other products that we have for millimeter wave. Starting on the left, you see the 60 gigahertz solution that we have. That's the Street Node V60 point-to-point. This is a 1.6 gigabit full duplex radio. It's a very compact radio designed for street deployment. And what's really interesting in this has the antenna embedded inside, and it's a self-aligning antenna. To the right of that, going into the 70, 80 gigahertz radios, we have the UltraLink FX80, which is a 3 gigabit full duplex solution. And then we also have the UltraLink BX70, a 1.6 gigabit TDD radio designed for the enterprise deployments. Last but not least, there's also the UltraLink XR80, which is a 30 gigabit full duplex solution that is part of our roadmap. I also wanted to mention very quickly the dual band antenna solution benefits. This is the case of a greenfield solution, as we discussed, that basically attaches the third-party microwave. Again, it could be anything, whether it's licensed or unlicensed, it's going to work. It's vendor agnostic. So the UltraLink GX80, the E band attaches right here, and the custom-made cassette for the third-party microwave is right here. The main idea is that instead of two antennas like in the brownfield, instead of installing and handling one antenna for the microwave and not one antenna for the E band, you now have your logistics and handling reduced by 50% because everything is done with one antenna. The same kind of concept for the required space on the pole, that gets reduced, as well as the installation and alignment time, again, because there's no need to align and install two antennas. Now, where did we do this great reference that we've been talking about earlier? That's at Rapid Systems. So this is the reference in Florida. Rapid Systems is an ISP located in Tampa, Florida. They offer fixed wireless services to 11 counties there. So the issue they had was that their existing 11 gigahertz microwave link, it was not enough. In other words, they wanted to offer more capacity, but the capacity there was maxed out. So they talked to us. We discussed the option for the UltraLink GX80, as well as the dual band overbuild, and we made it work. This is a reference with tremendous performance, and it is a great reference, not only for the actual RF performance of the link, but it shows you again that the system gain, delivering the highest system gain in the market at 10 gigabits, is what really drives the 8-mile deployment and high capacities to 9 and beyond gigabits. And this particular case helped Rapid Systems deliver the high capacities, the fiber-like high capacities when fiber was not available in the rural area. That's why it's a great reference. But what's in the heart of it? What makes this great performance work? And the answer is the modem. Long time ago, we decided we want to invest in our own modem. We didn't want to have the approach of a third-party solution, off the shelf like some of our competitors. So we did it. We invested in-house design, and we created this modem that is customized per product. It has a fantastic MTBF, supports up to 1024 QAM for E band, and it does have the highest spectral efficiency at 80 gigahertz. This is because we are the only vendor that can deliver 10 gigabit with a 1500 megahertz channel. Everybody else requires 2000 megahertz. Of course, we deliver the capacity with 2000, but our primary target was to do it with 1500, and we did it. We achieved it because of this high spectral efficiency of our modem. Let's look at the radio itself, the product highlights. What you see here is the picture on the right that shows you the interfaces of the radio. It's a radio FDD mode that functions between 7176 and 8186 gigahertz with different configuration methods. You see the different channels supported, the 15 megahertz channel circled here in black. That's our primary advantage for the spectral efficiency. 1024 QAM modulation capability. And you see the most important part, the system gain at 10 gigabits. So you see that it exceeds 70 dB. The specific number is 70.6 dB, and that's the market leader at 10 gigabits. Now the unit is basically designed for carrier use. So it has a carrier Ethernet networking functionality embedded because it's a switch. You can see the different ports. You can drop traffic at the end of the link, so you don't need any switch there. You can do that directly to your end customers. It has advanced packet synchronization methods, whether it's transparent clock, boundary clock, sync-key, all of that associated with very, very serious backhauling requirements. And on top of that, it supports Ethernet mode as well as CPRI, again for backhaul in one unit with just the software. So one unit that supports both modes. So basically, it covers completely a tier one operator, that wants to have very strict backhaul requirements, and all the way to simple pipe, from point A to point B, delivering the highest performance at 10 gigabits in the market. Also want to mention very briefly that this radio is IP/MPLS ready. So with just a software license, we provide the IP/MPLS capability. So if you want to hide your network complexity, you can do that by extending the IP/MPLS network all the way to the edge of your customers. And you can increase the flexibility and service of your portfolio, so you're not limited to layer 2 VPN now. You can also do layer 3 VPN for your enterprise customers. You can improve bandwidth utilization and end-to-end quality of service, as well as make fault detection very easy because it simplifies your network operations and maintenance. Now, if you guys are interested, we have a great trial program for the UltraLink GX80. We work together, and the main idea is that you identify the site details. You tell us where point A is, point B, about the existing infrastructure that is found there, the installation details. We engineer the right solution for you, and then we collectively define the success criteria. We do the RF planning for you. And if you have, for example, any additional tests that you want to do during the trial using your existing infrastructure, we'll be more than happy to assist you in defining those, the success criteria, and we fully support you during the entire implementation. Now, before we go into the Q&A session, I'd like to very quickly summarize some of the things that we talked about here. The main takeaways here are basically E-band being a fantastic option to deliver high capacities in a very cost-effective way. It's license exempt, very lightly licensed band. Key element, however, in order to do this is to think in terms of beyond the concept of a limited delivery of this band between 4 to 5 miles. We showed you a reference that is very, very serious about how you can think in terms of delivering service, high capacity service to 10 gigabits beyond 8 miles. Obviously, this case, even though it because of that system gain being the highest system gain in the market for the UltraLink GX80, the Intracom Telecom E-band radio, you need to make sure that when the weather does not permit that high capacity to be delivered, you protect that. That's where the dual band overbuild comes into play. And this guarantees that you have the radio that delivers that high capacity, the long distance, and makes sense because it gives you another option when fiber is not available. So you got an excellent option, a radio that is top performing at a very cost-effective price, very, very, very normal price. And it basically bridges the best of both worlds, whether it's the WISP requirements as well as tier 1 operators that may need to have very strict backhaul requirements. So a WISP gets the best out of both worlds in a market-leading system gain radio that can help you deliver high capacities at the long distance. So in other words, there is a radio that can deliver those capacities at a much bigger, a much longer distance than what we have been traditionally thinking of.